Hey guys, Mr. Riz here to help you out on the 4.5 section here. And what we're going to be doing now is solving rational expressions. So we've learned to multiply, divide them, add them, subtract them. Now we're going to combine it together and to solve them. So solving means we're going to figure out a value for x here and try to solve it. One thing we're going to have to watch out for, something new that you didn't have to worry about with most other equations, is to find extraneous solutions. So that means sometimes we can find an answer, and when we look back at the original problem, that answer doesn't quite work. So let's look at this. Let's start with some easy ones here, and then we'll build off. Okay, so the one thing that we got here is that easiest problem that we can look at is this one here. So we can always solve a problem here if we're trying to solve for x by multiplying the other side by the denominator. When we do that, if you remember here, that will cancel out this denominator here, and all we have to do is to distribute this 2 here. So we get 1 left over. The numerator is equal to 2x plus 8 because we got the 2 times the x and the 2 times the 4. We can then just minus the 8 over, divide by 2, and x would equal -7 over 2. The one thing that we're going to note here, and this is going to bring up extraneous solutions, is that we're also going to say that x cannot equal -4. Okay. We know that here, and it doesn't matter because x equals -7 over 2, but we also want to make sure, because the denominator here, we can never have that equal to 0. So when we set up our problem here, we just need to make sure that that never equals 0. All right, so let's see if you guys could try one of these easy ones on your own. If you want to watch, I'm going to do both, but if you can pause the video anytime. Also apologize, I still have to use the mouse here, but we're going to do what we can. Okay, so let's go through this first one here. We're going to multiply the other side by the x plus 5. So we get 2 equals 4 times x plus 5. All right, so we'll leave the 2 alone. We'll distribute the 4. So 4 times x is 4x. 4 times 5 is 20. All right. Then let's minus the 20 over. So if we minus that from 2, that's -18 equals 4x. And then we'll divide by 4. Okay, so that means x would equal -18 over 4, and that does reduce. That is -9 over 2. Okay, hopefully you got it right. All right, check the other one out here. If you want to pause the video, try it on your own, but let's see we do this. Okay, so we're going to multiply. We're going to leave the 1 alone. We're going to have to multiply the other side by the x minus 7. Okay, so that means we get 1 equals 2 times x is 2x. 2 times -7 is -14. We're going to add the 14 over to the other side. So, okay, we get 15 equals 2x. And then we divide by 2, and that doesn't reduce. It's just 15 over 2. Okay. The one thing to do note here, you didn't have to worry about this here, but on this first problem here, we'd have to make sure that x never equaled -5. So if we got that as our solution, we'd have to watch out. Same thing here, we'd have to make sure that x cannot equal 7. We didn't get that as our solution, so we didn't have to worry about that problem. Okay. So let's talk about how we can go through and apply this to some story problems, because that's pretty much what we always want to do. You know, how can we relate this to something? So Arthur and Cheyenne can paint a wall in 6 hours when they work together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she was working by herself? Okay, so the first thing we want to do with like these rate problems is to determine their work rate. So we can let x represent the number of hours Arthur needs to paint the wall by himself, and the fraction of the job is completed per hour is his work rate. So Arthur can paint 1 wall in x hours, or 1 over x for the number of walls in 1 hour. Okay. Cheyenne can paint twice as fast, so Cheyenne paints 2 over x, meaning she can paint 2 of them over the amount of hours, so 2 in 1 hour. So together they can paint the wall in 6 hours, or 1 over 6. So we can set up the equation that if we have Arthur plus Cheyenne, that would equal 1 over 6. Okay, so 1 wall and Arthur's work rate 2 because she works twice as fast over Arthur's work week. And we can go through, set it up. So to solve, what we can do here is we can add these two together, and then we can multiply across, and then we go through and solve. All right, so let's try to do this one on our own, see if we can figure this out. So it takes 12 hours to fill up a pool with 2 pipes, where one water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? Okay, so we always start with the slower one. Let's say, so the slower one is 1 over x, plus the faster one's 3 times as fast, 3 over x. We know together they can get one pool filled in 12 hours. Okay, so what I like to do, I like to add my fractions first. All right, they have common denominators, so we can rewrite this problem as, okay, well, 1 plus 3, that's 4, and we don't have to worry about anything else. The other common denominator is x, okay, is equal to 1 over 12. Okay, and now that we can do this, we can just cross multiply here. Now, technically, we multiply this x times 1/12, and then we divide. But if you guys remember, when we have fractions set up, you just have to multiply. X times 1 is x, and 4 times 12 is 48. So the one pipe all by itself would take 48 hours. We could do the math too to try to figure out the faster pipe. It would be 3 times as fast. And so that would be what, 16 hours, I think, for the other one. Okay. All right, next, what if we have some more complicated problems here? So if you remember here, we could go through and try to figure out, okay, what our solutions are missing here by adding these together. We'd have to get common denominators. So we'd go through common denominators like we did. We set up, simplify some things, and we would cross multiply. The one thing we have to watch out for when we start solving is we can have some extraneous solutions. Meaning if we go through this problem and solve it, we can figure out, okay, x equals 5 and x equals -1. What we have to do is to double check, do any of those solutions make the original problem have a denominator equal to 0? And you can see with this 5 here is if we plug that back into the original problem here, that 5 would make that denominator equal to 0. So it wouldn't work. It'd be a no, that one doesn't work. So I wouldn't say no solution, but that is the only one that doesn't work. The only one that does is the -1. Okay, so we're definitely going to take our time with these ones here. I like to go through and kind of add these together, combining, working on our section 4.4. But let's see. All right, so if I were going to try to add these fractions together, I'd have to get a common denominator. Luckily, these problems are set up a little bit easier than the 4.4 section. But you can see this is an x plus 2, this is an x minus 2, and then this is an x plus 2 and an x minus 2. So this problem over here, this first one needs an x minus 2 on the top and bottom. X minus 2 times 1 over x plus 2, x minus 2. All right. Plus this one here needs an x plus 2. It already has an x minus 2. So it needed an x plus 2. And then the one at the end, we don't have to do anything to, so we're just going to leave the 4 alone because it already has an x plus 2 and x minus 2. Okay, so what we can do now is we can have our x plus 2, x minus 2. Equal to, okay, over here we have our 4, x plus 2, x minus 2. Okay, so what we can do here is we can distribute these and add these. Well, if we're just distributing one, it really doesn't change too much together. We would just have one x plus another x here, so this would be a 2x. And then we'd have a minus 2 and a plus 2, which would actually cancel out, right? Minus 2 and a plus 2. Okay, so this next part here, there's a simpler way to do this, but I'm gonna show you guys kind of the complicated way, and I'm gonna apologize because it's gonna get real messy here. All right, so technically we're gonna cross multiply here. Let's first do this part here. We can understand that these two are gonna cancel out. So really we have a 2x times the x plus 2 and the x minus 2. And then on the other side, we would have the 4 times the x plus 2. Oh, you know what? That should be an x minus 2. I don't know why I wrote a 4. Probably because I was looking up ahead, right? I put a 4 there as well. It's probably looking up ahead. The x plus 2, x minus 2. Okay, so we should technically do this step where we cross multiply. We take all the factors here, multiply it by the numerator on that side. We take the numerator over here and multiply it by all the factors over there. Now, what ends up being nice here is that we have all these factors on the left and all these factors on the right. And technically, we could divide or cancel out anything that they both have. So both of these have an x plus 2 on each side. Both of them have an x minus 2 on each side. And what's left over is just the 2x, and then the other side is 4. So now that's a much easier problem here. We can just divide by 2 and we get x equals 2. Okay, so that doesn't always work out super nice, but there we go. We figured out x would have to equal 2. Here's the catch. We need to double check to see, can that ever make any of the original denominators equal to 0? If it can, we're going to cross it off. All right, so if we plug 2 back into this denominator here, 2 plus 2 is 4. That's good. We got to double check for all of them. 2 minus 2 is 0. Okay, that's bad. So that means we cannot accept this answer, and that is the only answer we got. And if we can't accept it, that means we have no solution. Okay. So that can happen too. All right. So things can kind of get more complicated just depending on what we have here. So this is nice. We have a common denominator here. We have a common denominator here. The problem is that this 7 doesn't have a common denominator. So if we wanted to simplify this here, we'd have to get the common denominator by multiplying that 7 times that x minus 2. And then we go through and solve. And we can plug that back in just like how we did there. If we got x equals 2, if we plug that in, it doesn't work out. Okay. So same thing here. If we look at these, the denominators are the x minus 3, and 4. So we'd have to multiply this side by 4. We'd have to multiply this side by 4 and this side by x minus 3. We all get a common denominator and we can solve from there. This problem ends up factoring. So we get 2 solutions here. We get 3 and 4, but we double check to see if any of them work. The 3 does not work and only the 4 does. So 4 is the only solution here. Okay, so one thing too to try to think about, since we're always getting these common denominators, and this is kind of a trick, to save our work, we really only need to multiply the top by the denominator piece that it's missing. Okay, so when I look at this problem here, all right, technically that's over 1. I would look to see this and say, okay, x minus 3, and a 1. So what this one is missing here is an x minus 3. So I'm writing kind of small. This one here is missing a 1, so I'm going to times it by 1, which means I'm not going to change it. And this one here is going to times by 1. Then we don't really have to worry about the denominators. So we're going to take our x and times it by an x minus 3. We'll leave the 6 alone, and we'll leave the 2x alone. This will actually save a lot of space here, make our work easier. Though technically we are doing all the common denominator stuff. Remember, this is just kind of a shortcut here to make our work simpler. All right, so let's distribute here. We have x times x is x squared minus x times 3 is 3x. And then we have plus 6 equals 2x. Okay, so we haven't seen this yet, but this can happen. This is a quadratic. So to solve a quadratic, we need to make it equal to 0. So we're going to minus that 2x over. And would get x squared minus 5x plus 6 equals 0. And we're going to factor it. So what two numbers can multiply together to give us 6 and add together to get -5? All right, it's not 6 and 1 because 6 times 1 is 6, but that'd be -6 if we multiply it. It would have to be an x minus 2 and an x minus 3. All right, so that means our two solutions are what makes this factors, or each one of these factors, equal to 0. You remember, it's just kind of opposite. So x would equal +2 and x would equal +3. All right, so what we have to do now is to check for extraneous solutions. So can any of these problems here, if we plug them back into the denominator, does it make it equal to 0? If I plug 2 back in for x, okay, 2 minus 3 is -1, 2 minus 3 is -1. So 2 works. It can be plugged into any of these denominators for x, it works. If we plug in 3, 3 minus 3 is 0. That doesn't work. So the only answer that works is 2. Okay, go ahead, try the next one on your own if you want to see if you're feeling all right with this. And then we'll see how we're doing here. Okay, let's get this started. All right, so if we look at this denominator is x plus 5, that denominator is x plus 5. We actually don't need to multiply anything. So the denominators cancel each other out. We have x squared equals 25. Now we could go through this and factor it, or we can just remember if this is an x squared, we can take the square root of 25. We just have to remember anytime we take the square root, we get a positive and negative answer. So we get two answers here of x equals +5 and x equals -5. What we need to do though is to check, can any one of those answers, if we plug it into the denominator, will it make it equal 0? If we plug 5 into the denominator, 5 plus 5 is 10. That is not 0. That's a good answer. If we plug -5 in, -5 plus 5, that's 0. That doesn't work out. Okay. All right. So the next step here is to go through and apply this to story problems here. So we got a problem here. We got paddling with a current in a river. So Jake has traveled 60 miles, even though he paddled upstream for an hour longer than the amount that he, let me say that again. He paddled upstream for an hour longer than the amount of time he paddled downstream. Jake could only travel 6 miles against the current. All right. In still water, Jake paddles at a rate of 5 miles per hour. What is the speed of the current? Okay, so let's talk about this here. So let's see, paddling with the current. I was thinking 60 miles total. So when he goes downstream, he's getting that speed added to his distance here, or his miles per hour with that, and that's 60 miles per hour. And even though he paddled an hour longer upstream, so he paddled twice as long, he only went 6. So that's going to have to make a difference here. So if we try to think about this, is distance is rate times time. So we can say time is also the distance divided by the rate. So we can actually set up two equations here, and we can say, hey, if we had 16, which is the distance of 5 plus the current, so his standard paddling speed plus the current plus another hour, all right, that would equal his upstream speed divided by 5 minus c. So he's losing that. So we can see, okay, what are the denominators missing here? This one's missing a 5 minus c. This one's missing a 5 plus c and a 5 minus c. And this one's here missing a 5 plus c. So we can distribute all that work out. We end up getting a quadratic. We solve for those. And then we're going to plug those back in to see which one makes sense. Now, we actually can plug both of those in and we get -25 and 3, and both of those work. But you think about a current would never have a negative speed. So we're going to stick with the one that's positive. Okay, so let's give this one a try here and we'll see how we do. Okay, guys, I'm going to try this again. My computer froze and I didn't get this very last question answered. So let's go through this here. We got 3 people that are planting tomatoes in a community garden. It takes 50 minutes to plant the garden alone. Martha takes 50 minutes to plant the garden alone. Benito takes X minutes and Tyler takes X plus 15 minutes. Right? If the 3 of them take 20 minutes to finish the garden together, How long will it take Tyler alone? Okay, so what we're going to do is to set up a bunch of ratios here. So we know that Marcia can get one garden done in 50 minutes. And Benito can get one garden done in X minutes. And Tyler can get one garden done in X plus 15 minutes. And if we put all three of them working together, Martha, Benito, and Tyler, they can get one garden. So that would equal one garden over 20 minutes. Okay, so what we got to do here is we need to solve for X. If you look at this, we have basically like 4 different denominators, and it's kind of unfortunate, but it's going to get crazy. What we have to do here is we need to multiply each numerator by the denominators that it's missing. Luckily, these are all ones, and so it's not going to really change too much. So this 1 over 50, to get a common denominator, we're going to have to multiply by, I guess we could use smaller numbers here, but we're going to have to multiply it by the X because it doesn't have an X. We're going to have to multiply it by the X plus 15 and also by the 20. So we're going to take the 1 and we're going to multiply. Now I'm going to put it in a little bit better order, but we're going to do like the 20 and then the X and then the X plus 15. All right, because that's what this first term is missing, right? It's got the 50, it's just missing the other 3. All right, then plus. All right, now this next one here, it's missing the 50 and it's missing the 20 and it's missing the X plus 15. Okay, so we're just making common denominators here. We kind of know the trick is like all we need to do is multiply the numerator, which in this case for every single one is 1, by what it is missing. All right, then we got our next number here. Change the red. All right, this is the X plus 15, so it's missing the 50, it's missing the 20, and it's missing just the X. We're going to set this equal to. All right, now this one has the 20, so it's missing the other 3. It's missing the 50, missing the X, and missing the X plus 15. Okay, so what we got to do now is we got to kind of distribute all this out. So let's definitely take our time here doing this. Let's see. Now keep in mind, like this is 20x, so we're going to take 20x and distribute it to those two. And so 20x times x is 20x squared. 20x times 15 is, let's see, that'd be 300x. Next, we're going to take these two here, which is 50 and 20, that's 1,000, and we'll distribute to those two. So 50 or 1,000 times x is 1,000x. Oh, one more 0. And 1,000 times 15 is 15,000. Okay, so large numbers here, but we'll be able to deal with them. 15,000. Okay. Next, we're going to take that 1520, that's 1,000, and we're just going to times it by the x because that's the only thing there. And so that's 1,000x. And then over on the other side here, we have 50 and x. So that's 50x, which will distribute to the x and the 15. So 50x times x is 50x squared. And then let's see, 50 times 15, that is 750. And then x. There's the x. Okay, so we distribute that out. Let's see, I need a little bit more room, so I'm going to scooch that down a little bit here. Take all the work. Didn't need to make it smaller. Want to move it. All right, let's move it here so we have some more room. All right, so now what we need to do is we need to, this is a quadratic, and we can tell it's a quadratic because we have x squareds and x's and just regular numbers. So any quadratic, we need to make it equal to 0 to solve. So I'm going to minus this 50x squared away from the 20x squared, and that'd be negative 30x squared. And then let's see all of our x's, because I'm going to minus the 750 over. Let's see, we got 300 and 1,000 and another 1,000. So that's 2,300. If we subtract 750, that would be still positive 1,550. Yeah. X. And then we have this 15,000 all by itself. Okay. So this is a quadratic. We can go through and try to set it equal to 0 and then try to factor it. But these numbers are fairly large. So a trick we can do here is to see, is there anything we can divide all of them by? And we can divide them all by just -10. Okay, so that would be a 3x squared. Just make our number smaller, easier to use. We could just use all these big numbers in the quadratic formula. It would work, but it might get really large and scary. All right. If we divide that by -10, that makes it a -155x. If we divide 15,000 by -10, that makes it a -1,500. And 0 divided by -10 is still 0. Okay, so now we have a problem that's slightly easier to factor. We still have a very large number here because we have to do what two numbers multiplied together to give us 3 times -15, that is -4,500. And then add together in the middle to get -155. All right, so we put on our thinking cap. Oh, let's see, 4,500. Okay, thank you, skateboarding. All right, that would be 180 and a -25. All right, so that means this factors to an x plus 180 and then an x minus 25. And then we'll still have equals 0, but we had a number in front, so we get divide by that number in front, and we got to either simplify and or slide our fractions. Okay, so 180 does divide by 3. That is, actually, you know what? I have my positive and negatives mixed up. Just looking at this here, we're gonna have to change some things, right? Not gonna change too much. Nope. This should have been a -180 and a positive 25 to get the -155. So that's a -180 and that's a positive 25. Doesn't change too much. All right, so we get not x plus, but we get x minus 60. And then here, 25 over 3 doesn't reduce, so we'll just do 3x plus 25. All right, so we set both of these equal to 0 and we solve for x. So that means x could equal 60, so it takes 60 minutes, or x could equal -25 over 3 minutes, which is like -8 1/3 minutes. All right, so remember with any of these problems here, we have to look for extraneous solutions, answers that just don't make sense. It wouldn't make sense that it would take them -25 over 3 minutes. That doesn't work, you can't get it done before you get it started. So does 60 make sense? Yes, and we double check and we plug it in. Now, I believe the question says, I'm going to clear this off here. All right, so x is 60, so it would take Benito 60 minutes, and it would take Tyler 60 plus 15, meaning it would take Tyler alone 75 minutes, an hour 15 to get the garden done alone. All right, guys, so redid this video. Hopefully you guys probably don't even notice the transition. Well, you probably noticed the transition, but it was just a mistake at the end. All right, so when we're looking at the section here, guys, at the end, remember when it comes to solving rational equations, you just have to see like what the denominators are missing. All right, this side over here, they all have x's, they're missing a 6. So you multiply both of those by 6. This one's over here missing the x. So 6 and 12, and then over here's the x. You just solve from there. And when it's a more complicated expression here, you just see what they're missing, and you can go through solve. You always need to double check for extraneous solutions because you could get an answer that when you plug it back in, it just doesn't work out. All right, guys, have a good one. Thank you for watching, and I'll see you guys later.